So in this lesson, we're continuing our implicit differentiation, but now finding the slope of now our tangent line at a given point. So remember now, because we're focusing on implicit, so like for example, this graph here does not represent a function, all right? So this is an implicit equation. Like for example, here is the equation of our graph. This is clearly implicit and this graph is not a function. Now remember to find slope of a tangent line. That is the derivative. So here we are solving for the slope, the derivative, the dy over dx. So that's why here, what we practiced before, we're looking for the actual slope. We got to find the equation of the slope of the tangent line, the derivative. But now we're going to take it a step further because now we're given a point. We're going to be given what is x, what is y. So like visually, for example, we're looking at the slope of this tangent line here. Notice how at the point 3, 3. So here, if I were, and here's our graph. So what is the slope of the tangent line here at the point 3, 3? -1. So that is our slope, like if we were to say our m. This is now what we're going to be focusing on. We're getting that value here that represents the slope of our line going through a point, but of an implicit function. So like here, for example, we are going to find the slope of our tangent line given the point going through the point -1, 1. So at this point specifically. So just like before, right? We got to find the derivative. So we are solving for dy over dx. So we've got the derivative of 2, which is 0. Remember, right? Don't leave it as a 2 because we're taking the derivative. So derivative of a constant is 0. So 0 is equal to, here I've got 12x cubed, then plus. Now notice we do have product rule. So we're going to take the derivative of x first, which is just 1. So that's 1 times y to the 4th, or just y to the 4th. Then plus. Now we're going to take the derivative of y, which is 4y cubed times x. Now remember, right, because we just took the derivative of y, and that is in terms of y, so dy over dx. So now one thing I'll show you is here we're used to then solving for dy or dx, and then that's our answer. But if I just want to know what is that one value, the slope, and looking for here, one way, and I'll show you with this one, is let's just go ahead now and plug in our value for x and value for y now that we've got our derivative equation. So 0 is equal to 12 times x to the 3rd power. Well, what is x? -1. Then plus y to the 4th. What is y? 1. Plus 4 times, what is y to the 3rd power? 1 to the 3rd power times x, -1, dy over dx. So now here we can go through and simplify. So this is -1 cubed, which is still -1. So 12 times -1, -12. Plus 1 from 1 to the 4th. Then here, remember now, right, this is all being multiplied. This is our coefficient to dy over dx. So when you simplify, that's 1, but times -4, so -4 dy over dx. So here I've got -11, and then -4 dy dx. Now we're solving our equation for dy dx. I'm going to add 11, so 11 is equal to -4 dy over dx, and divide by -4 because that's what's being multiplied. So the slope of the equation of the tangent line to our function here is -11/4. That is the slope of the tangent line going through the point -1, 1. So here, let's again find our derivative. So I've got 2x plus 2y, but again, that was derivative of y, then plus 0. So we'll just leave that, is equal to 2 plus 12 dy dx, right? Because we took the derivative of y. We're talking about this x value, this y value. Now here, if you wanted to, you could go back to how we had solved in the past, where we would gather the variables and divide out, but I'll go ahead and continue with substituting. So this is 2 times x, or 2 times 4, plus 2 times y, which is 3 dy dx. That is equal to 2 plus 12 times dy dx, because there was no x or y. So here to simplify, we've got 8 plus, here I've got 6 times dy dx, which is equal to 2 plus 12 dy dx. So now I'll gather. I can subtract 2 here. So I'll subtract 2 to gather. We could also subtract 6 dy dx to gather our common term together. So now we've got 6 is equal to 6 dy dx. So now notice, what do we have to do to solve? Divide by 6. And now notice here, our slope of the tangent line of our function through this point is 1. So go ahead and pause the video now and try the 2 u-tries on your own, right? So take the derivative, and then here you can substitute x and y to solve for dy dx, your slope of your tangent line. And here we go. So again, the derivative, you should have 2x minus 2y dy dx is equal to 0. Now I'll go ahead and substitute my x and y. 2 times x is, or 2 times x, or 2 times 6, minus 2 times y, or -3, then dy dx is equal to 0. So now here I've got 12 plus 6, right, from negative times negative, dy dx is equal to 0. Now we're just solving for dy dx. We're adding 12, so subtract 12. I've got 6 times dy dx is equal to -12. Then divide by 6 because that's what's being multiplied. So the slope of the tangent line is -2 here. So then here, take the derivative. You've got 12y cubed dy dx is equal to 4x cubed minus 6x squared at this function. So now here, I am going to go ahead and just solve for dy dx now as is, because see how it's just by itself? I'm going to go ahead, for those who wanted to try it, now you could have substituted. I'll do a little differently here. I'm going to go ahead and divide by 12y cubed. So now I've got dy dx is equal to my function here. So now I'm going to go ahead and plug in. So 4 times x, which is -1 to the third power, minus 6 times x again, which was -1 to the second power, divided by 12 times y, which is 1 to the third power. Now simplify. So here we've got, that's -1 times 4, -4. Notice this is -1 squared, which is +1, so -6. So -6 times 1, -6, over 12, from 1 to the third, which is 1, times 12. Here we've got -10 over 12, which simplifies to our slope of our tangent line, -5/6, -5/6.